This podcast is brought to you by Ingrok. If data is the lifeblood of a modern IT organization, Ingrok is the circulatory system moving that data from where it is to where it needs to be with a seamless, easy-to-use SaaS offering. Maybe you're trying to standardize the application delivery policies for your organization across multiple data centers or cloud environments. Or you're building a SaaS offering that needs to deploy and manage software inside customers' networks that you don't control. Or you need to be able to connect to IoT devices regardless of which network those devices live on. Ingrok allows you to access that data in a way that is both developer and CISO friendly. For more information, contact Ingrok today. And now, on to our show.
Can I get the icon in cornflower blue?
Hey everybody, welcome to episode 35 of Can I Get That Software in Blue? I'm one of your hosts, Chad Tyndall. Along with me is my co-host, the man, the myth, the executive formerly known as the Sultana of Grafana and the Emperor of Empathy. He's returned back to the home where we first met to become the alchemist of AI at Elastic, where he can brag that they have the best rag. Steve Mazak, everybody.
Chad, thank you. Thank you for having me on the show. I appreciate it. Your intros are always great.
It's your show too. What do you mean having you on the show? You're a co-host.
Every time you do that, it makes me feel like I'm an esteemed guest or something.
You are. You're an esteemed co-host. We'll call you an esteemed co-host. How about that?
Oh yeah, that's even better.
Well, it's been a few months since we recorded our last episode. I think you've been super busy having gone back to work at Elastic and ramping up in the AI space there. So tell us about that. What are you working on now? And what made you boomerang?
Well, so, having left Elastic, I felt like Elastic was the best place I ever worked. I was like, I'm going to go try and, capture that lightning in a bottle again. But that wasn't in the cards. And I was testing a few theories about observability, which is why I joined Grafana. But those didn't turn out to be what I thought they would be. And then I just decided I wanted to get into AI. So I went to Empathic. And, the Empathic thing was like, I'm going to join for 6 months and see if I can help the company. But I don't think we were ready for a go-to-market person at Empathic like me. They still needed the domain expert in Grin, the founder. And with ChatGPT launching, we had to pivot. And so Empathic pivoted back towards pharmacovigilance, and they're finding a lot of success there. So that's a really good move, but it wasn't for me. And I saw Elastic continue to announce all this AI stuff, right? They came out with Esri. They were getting into the Gen AI space in a big way. And then we had Matt Riley on the podcast. And after that podcast, I called Matt and I was like, hey, I would love to, talk to you about coming to work for you at Elastic. And long story short, I'm back and I'm working on the AI and search area of Elastic. So I'm working with Matt to get the word out about our vector database. We built a vector database into Lucene, and we say it's the world's most downloaded vector database because Lucene is such a hugely popular product and there's a vector database built in. Yeah. So this idea that LLMs can do all these things is great, but they have their own limitations. And so this RAG architecture or pattern has come out that allows you to get the most out of LLMs while minimizing all the risks like hallucinations and security issues and temporal data, stuff like that. So it's a really fun area to work in. And I couldn't be happier to be back at Elastic because it still has that feel that I left, that I was craving. And quite frankly, there's a lot of boomerangs. One of the reps I used to work with, Sunaina, just came back and her and I are teaming up. She's now in the PM organization or PMM organization. There's a few SAs that are coming back now. So Elastic still has some magic.
100%.
Yeah.
Yeah, well, Shai's still there. So I'm sure the culture hasn't changed that much with the founder still there.
I feel like after working for Shai, I really can't work for anyone that's not like Shai.
He's amazing.
You don't suffer fools, no bullshit. But very empathetic and understanding, just very stern and has his direction. And I like that.
Yeah.
So.
No, he's a great leader. I know you also bought an Apple Vision Pro recently. And from what I hear from you, they're basically permanently attached to your face all day, except for right now. Yeah, you go. So what's your experience been like in the virtual world there?
I think it's awesome. The thing is really well designed. It just kind of looks cool, I think. And what surprised me is that, it's got the better than 4K screen, I guess. So the screen door effect that I'm used to in my Quest 2 and Quest 3 is no longer. And that kind of was a game changer because now it doesn't feel like you're looking through this kind of half-baked device.
Right. Super high res.
Super high res. And then I've been trying to use it in different scenarios like conference calls. Although when you do that, it's kind of weird because it uses your digital avatar. It does weird things with your face and the sides of your head look weird. I play D&D with my brothers and my nephews every once in a while, and we played when I had the headset on, and that was amazing because I could have all the D&D windows up around me because we use D&D Beyond. While we play, I can be on Dolly generating images for fun. I can walk around and let the dogs out, and I have this computer attached to my face.
And all the gestures for D&D, it's just with your hands.
Well, it's just like tabletop, right? So we're rolling dice and stuff like that. So I don't know. It's not an actual video game, right? It's a role play, the old school tabletop game.
Oh, I see.
Yeah. So we just play online. So we're all on video and we all use this app, D&D Beyond. But so that's cool. And then the other killer feature is watching 3D movies, and especially on a plane. I was really worried about looking stupid the first time I used it on a plane. But as soon as I started watching the movie in 3D, I was like, I don't care what I look like. This is amazing.
That make a plane flight a lot more fun.
Yeah. So I think the 3D movie aspect is like a huge game changer for that format. And I really, before this, I didn't really care for 3D movies because you have to wear the glasses and it's annoying.
Oh yeah, because they're projecting each eye independently. They can get the same effect without special glasses.
Exactly. And then Apple's been releasing these little experiences, these virtual reality experiences. So they recorded like 5 minutes of MLS footage, Major League Soccer in the US. And it's all like on the field, right by the goalie, in the locker room. And it feels like you're there on the field or you're in the locker room with the team. Like it's incredible. So I can't wait for more stuff to come out. I'm disappointed that Apple hasn't seemed to be investing in apps. Microsoft just released a native Vision AVP OneNote app, and Apple still doesn't have most of their apps on there other than just, here's Safari, use Safari,
That's strange. It does feel like something that Steve Jobs would have made sure that there was some native apps built in and in the V1,
I mean, there's a few, but it's like, it just feels light right now. But there was some comment online the other day where someone was saying like in the early days of the App Store, it was kind of the same thing. And I do remember that. Like,
it takes time.
There wasn't even a calculator, I think, on the original iPhone.
All right, we have a very special guest today. Some of you may remember back in episode 30 when we interviewed Earl Mitchell that I mentioned I really enjoyed talking with people who studied physics because not only are they just generally crazy smart, but their brain is trained to think in abstractions, which kind of seems to allow them to think deeply and understand and make connections between seemingly unrelated topics, which I'm absolutely certain will be the case here today too. So welcome listeners to another thrilling edition where minds meet. Today we've got a guest whose feats are truly elite. Dr. Santona Tuli is her name, a scientist of fame with a PhD in physics. She plays the smartest games. She's delved deep into the mysteries at the heart of CERN, where particles collide and there's always more to learn. Featured in the documentary Secrets of the Universe, she's shown us the cosmic dance, and now at Upsolver as head of data, she peers into the big data expanse. From the smallest quarks to the vast data streams, Dr. Tuli explores the edges of our dreams, so buckle up for a journey enlightening and fun as we uncover the truths of the universe one by one. Dr. Santona Tuli, welcome to the show.
By far the best introduction I've ever had. Thank you.
I was going to say the same thing. It's amazing.
And that's what I'm shooting for. That's what I'm shooting. We've had 3 months, so, I've had some time to kind of think about this one and give some thoughts to it.
That's right.
Nice to have you here. I think we'll start you off with a nice, easy question, given that you worked at CERN and thought about all this stuff that's going on in the universe. Do you think aliens exist? Are we alone in the universe? What's your intuition tell you? What's your gut tell you?
So, I believe in the multiverse. So the chances are there, once you increase the denominator enough, right, even with a small numerator, you have, there's a possibility. I was recently watching the three-body problem, and I think the least interesting part for me was the aliens coming. Like, it was a lot more interesting in the beginning, where it's like, they're trying to figure out what's going on. Anyways, that's a non sequitur. I believe in the multiverse, and the reason I believe in it partly is not just scientific, but also because, I need to believe that, I'm very scared of collapsing the wave function and making decisions. So every time I'm looking for a new job and stuff like that, and what if that one's better, and then, or any other small decisions too. So I need to believe in the multiverse. There's another Santona that made that other decision, and then, infinite many more who made those other decisions and are having great lives. So with that said, I think that there is probably a multiverse where there are aliens.
What about this universe? What do you think? This one we're in right now.
I don't know. I think that it's very unlikely that we would actually meet them if they do exist.
Because it's so vast.
And also what would prevent, so let's say we sent out a signal, sort of like they show in the three-body problem, and they're advanced enough that they pick up the signal and stuff. What's preventing them from getting in the offense straight away. Like the intersection of we exist and we want to see if anyone else exists, and the other party also, like, we just want to sort of explore and learn and stuff, and having a nice meeting place in the middle, I think, is a lot smaller than, oh my gosh, what is happening? We need to, like, destroy these other people.
All right, good answer.
For all we know, they're observing us right now, and we're part of their reality show.
Yeah, possibly.
I don't want to think about that, Steve. That's creepy. Well, we've never asked a guest that question before, but we've never had someone with your background on the show before either. So thank you for that. I mean, I'm sure the multiverse is real. I believe in the simulation hypothesis, and I think it's very likely that we are just a simulation. So, I don't know if we're aliens reality TV experience, but
you never know.
You never know. It could be.
This is maybe actually going too deep, but I mean, I think about this almost constantly. Like, why on earth do we exist? What is the purpose? Why can we ask these questions, right? Like, why do we have the cognitive ability to process, the universe and why it exists and the secrets and whatnot? And it's like, we're so inconsequential.
Yeah, this tiny little rock floating in space.
I've heard from, like, the astronauts usually always say that when you go and you see the Earth from space, it changes your perspective entirely. It's like such a powerful moment. And maybe if space travel becomes a thing in our lifetime, that will start to change how we think.
Maybe SpaceX will be able to take vacations to Mars. I mean, I would do that for sure.
Yeah, Dr. Tuli, if we had a space station on the moon, would you go up there and do research? Would you hesitate? You wouldn't go up there?
Not until it was, like, really, really well tested. So I guess we're exposing the fact that I am very risk averse. I want to wait until things have been tested and really solid.
Yeah.
I don't know. Space kind of scares me. It's the movies where, like, you get detached from your group, and then it's like there's literally nothing to bring you back. So I was also thinking about this watching Godzilla and the new Godzilla and Kong movie. It's like they go into this portal to get to Hollow Earth, and like I would never willingly go through that portal.
I know. Can you imagine just jumping into a portal in the ground? No, thank you. All right, Santona, do you prefer I call you Dr. Tuli, or do you mind if I go back and forth?
Santona is great.
Santona is great. Okay, perfect. So, Santona, I noticed in your background you've worked at a lot of different places, and I can't wait to get into those details. I'm just curious, like, how did you get into this field? Like, what interested you in the initial early part of your life where this was interesting to you, where you've spent so many years doing it?
I'm going to take this pretty broadly here because I did work in physics, and then now I work in data. So when I was little, I wanted to be a scientist and an author. I think that kind of stuck. And I had a high school physics teacher who made learning physics really fun. I've always really enjoyed learning physics and math. I think it's the puzzle aspect that kind of gets me going. I don't mind not knowing something, but it definitely is like a bug in my head where I have to, like, work towards knowing it. When I don't know something, I'm very comfortable in asking the question because it's not about, like, showing how much I know. It's more about, like, learning. So I knew I was going to go into the sciences. I mean, my dad's an engineer. My whole family is in engineering or physics. Lots of things kind of aligned. I really enjoyed it. I've always had supportive. I've always been encouraged to do whatever I wanted, both from family and teachers and all of that. So I think just like a very nurturing environment where I could pursue what I wanted to pursue. Yeah, and then from physics, I was like, well, my partner is also, he has a physics PhD, also working in data. So we were like, well, we could both try to solve the two-body problem of finding somewhere to teach together, or we could, and we were in California at the time. I think he got in the sort of tail end of the first wave of data scientists, and I sort of got in the second wave of data scientists transitioning from physics. And it was actually a fairly common transition. So a lot of our friends were we would sort of sit and in our research in our research group offices, we would sort of sit and sometimes, like, talk about different problems that folks had been asked in interviews or, had as take homes and stuff. And you're like, how do you solve this? And then everyone has to one up everyone else and it's like, oh, have you considered this or this, this simple solution? So yeah, it's been fun.
Right on. So do you have an example of, like, some of those questions or a question that you get asked and you have to solve for these interviews?
I actually, during interviews, I really don't like the sort of like almost puzzle-like questions that are meant to be like gotchas. Like I remember during one interview early on, there was this Wumpus problem where it was a reinforcement learning problem, essentially. Like you sort of figure out how to best traverse a space and you fill with rewards and traps. And I was totally stumped by it. I'd never, solved that problem before. And it's one of those things where once you know how to solve it, you know how to solve it. So it's not really creativity. It's not really problem solving. It's more about like having a structure around it or knowing how to solve it. So I don't appreciate those questions, and I never ask those in my interviews. I'll go with sort of encouraging folks to talk about the work they've done and then sort of probe different areas within that.
Google interviews are the worst. Like, oh, I'm with you. I never understood the point of those types of interview questions, and it almost feels insulting. Like, oh, especially when you're a senior person. Like, I've been working in this field for 20 years. Like, think I don't know how to look up an algorithm to solve a problem if I need to? It's just crazy.
I was going to say, there've been questions that are like simple standard error, standard deviation type questions. Is like, this is kind of, high school math. It's like all over the place is the point.
Yeah, that's fair. I like to have people design things with me on an interview so I can see how they think, and then try to take them to a space they don't know very well to see if they can think through a new area using all of their kind of skills, right? Like, what do you do when you don't know? So, okay, if I ask a question, they say, I don't know how it works. Well, how do you think it works? And then just walk through it. And I've learned a ton that way on interviews, actually. So I like that.
It is nice when you can learn something from the other person on an interview. And also, if they put something on their resume and they say, I know how to do this, I'm going to ask them about it. And I'm going to see if they're being honest about it. Do you really know that? Let's see where the limits of your knowledge on this topic that you say you're an expert in are.
Yeah, which is not to say that you shouldn't put stuff that you like know somewhat but aren't an expert on, right? Because I've learned so much in interviews, like in both directions, but especially as an interviewee, like the first 3, 4, 6 months in the time between when I was still finishing up my PhD, but I knew that I wanted to work, I wanted a job in data. I just feel like that those 6 months were like 3 years of learning, honestly. Like it was so much, and I really appreciated that.
One time I was interviewing for a job and someone asked me a question. I was like, why are you asking me that question? They didn't really know what to say. I stumped them back. And I was just trying to understand what answer they're looking for, right? Because it was a kind of ambiguous question. So Chad and I were talking about your PhD write-up, and we noticed that you were using terminology like roadmaps and OKRs and stuff like that. And we were kind of curious, we never really thought about a university running programs like what we see in corporate America with OKRs and roadmaps and things like that. So is that fairly normal, or is that just kind of how you did it?
Did you read my dissertation?
The prep goes deep here. We go deep background.
Having worked with really massive data sets at CERN, I knew that I could do this job no problem. And I knew that I had a lot of the skills that I needed to do this job. And so I wasn't going to put up with any, you're a fresh graduate kind of thing. So I made it a goal to speak in the language that the interviewer would understand and appreciate, and is like this. So it was a very purposeful, intentional decision to take all of those skills and be able to represent them in corporate speak or business speak or startup speak.
So when you're doing research at a university, do you actually put milestones in the ground and try to think in terms of a roadmap where I want to get to? But it's got to be time bound, right? So it's not endless, I don't think.
Right. I mean, research isn't actually endless. Yes, of course you want to keep learning on a topic, but you do have milestones. You learn the answer to a broader question, and then you know what narrower question to ask, and then go iterate and so forth. So it's definitely milestone driven. And also since I worked in experimental physics, but we would work very closely with the phenomenologists who were coming up with the theories and sort of going back and forth, because the experiment helps constrain the theories. So it was a bit more perhaps structured than if you were doing pure theoretical work where you are really throwing things out there. So in that sense, we knew that we wanted to do a certain kind of analysis in order to find a certain kind of signal, which would help us constrain a certain parameter in a theoretical model. So in that sense, when you know that this is the kind of analysis you want to run, it's a bit easier to say, okay, in order to get those results, I'm going to have these five steps. And then the other aspect of it is in a detector, in a particle detector, like the CMS detector at CERN, there are almost routine stuff that you have to check off when you're doing an analysis. So for instance, the detector has hundreds of millions of different components, and some of them are going to be down or dead at any given time, and you can't really go in and fix it right away. So knowing sort of the known unknowns, like where are the gaps in my detectors, how do I fill them, how do I interpolate between the parts that are working, what is the overall efficiency of my detector, it's not going to pick up all the particles that are created. So those things are also a little bit sort of straightforward in some sense. You're not planning out the roadmap in the same way. You're not like, okay, this is, my final result is going to be here, and then in the path to it, I'm going to do these things. It's more, these are the set of things that need to happen. And then as a team lead, when you having a team of 4 or 5 folks, who's, you have to play to the strengths of different folks. So I don't like doing anything really in isolation. So I wasn't doing research in isolation either. I tried it for a summer. I worked with a theorist, and it was just them and me, and it was kind of miserable. So then I found a research group where it's more like sort of group oriented, team oriented, and so that sort of team experience and delegating to different people's strengths, the different parts, like all of that I learned in grad school, and that's definitely paid off in industry as well.
That's fascinating. So, number one, phenomenologist is a new word for me. I had to Google it. I think I want to change my job title, but also, how has this not been made into a rap song yet? I don't know, because it would be so easy to rhyme with. Second, like when you talk about the collection of skills that it takes to build a research team and play to each other's strengths, like, can you give me an example of what the overlap might be as you're trying to find one person with this particular set of skills, and then complementary skills? Like, what skills do you look for in your field?
So there's hiring a team, and there is inheriting a team, or being injected into a team. So it wasn't so much that we could seek out folks with complementary skills. It was more about developing skills together in a way that could be complementary, or with sufficient overlap skills so that everyone could sort of do everyone else's job. In our team, one of the things that sort of makes you a specialist in something, right, is having done it before. I was a person who was the efficiency person, so the detector efficiencies was my jam. I'd done it a few times before. Different folks were doing different subdomains within the broader analysis question, but of course everyone had to know where things played up. And I mean, part of being a team lead was also making, for me at least, I took it this way, making sure that we all understood why we were doing what we were doing. So it's easy to get lost when you're doing a part of a bigger thing. And of course, as the most senior person for the final analysis that I was leading, then I knew why we were doing what we were doing, and I wrote most of the paper and bring it all together, but sort of bringing everyone along on that journey of how does each of these pieces, how do they fit into the bigger picture, was very important as well.
I don't know how decisions get made around choosing which topics to research, which experiments to run, but I imagine it's heavily influenced by the people that are on the team. Have you seen it where the team composition is such that they want to study something that maybe isn't as interesting to you, and do you say, this isn't as interesting to me, I want to go do something else, or how does that work?
Yeah, so you self-select at CERN, and within the CMS collaboration, we have what's called physics interest groups. So those are broad areas of a topic of a physics area of interest, and then within those you have different working groups. So we were the heavy ion physics interest group, which means that we were interested in collisions of ions as opposed to protons, proton on proton. And I mean, of course, a collision type itself is not so interesting, as is the kind of physics that you can explore using that collision type. So really, the heavy ion group was about the strong nuclear force. We wanted to answer questions about quantum chromodynamics and the strong nuclear force, and the path to that was through heavy ion collisions. So that's the 60-person group within CMS, which is about 5,000 folks. that shared this physics interest. And then within that, we had different working groups for looking at, let's say there are 10 different channels through which you can probe the space, quantum chromodynamics. So we had 10 different working groups, and within those working groups, you have different particles that you specialize in. So we did a muon, a dimuon, so 2 muons being produced that could be reconstructed into a heavier particle. So, it's like levels on levels. And the funny thing, or funny, interesting, I guess, thing is that when you are doing an analysis and trying to get it published, then you have to get reviewed by each of those layers. So, you get sign off from the conveners, from the local group, and then bigger and bigger and bigger, until finally it's all the physicists in the world.
So I would imagine that if you do an experiment and then you publish the results, it has to be reviewed. In your world where you're doing something at CERN, it doesn't seem like it's going to be easy for other people to go and try and replicate the experiment to prove the results. Like, how does that work?
Yeah, also great question. So we do have a open data policy. So you can access all the data that CERN generates. I mean, it's not in the easiest format, and it's it's complicated, but
very domain specific.
Very domain specific. But even like getting access to the data, like it's a little bit annoying. But so there's that, and then to publish a paper, we have to do 2 other documents first. First is a really comprehensive analysis. I'm not sure what to call it even. It's almost like a little book. It's almost like a dissertation on its own. And then you summarize that into a smaller one. So let's say we're talking like 200 pages down to 60 pages, and then finally those 60 pages down to 2 pages if it's like a physics letters, or maybe a little bit longer. So that's all documented. Every choice that you're making in your analysis, including the GitHub repos where the code lives, including any sort of intermediary tables or data that you have created, everything should exist in that large analysis paper. So in theory, you'd be able to go and do it all and run it all and make sure that all the numbers make sense. Of course, in practice, no one else is likely to be running the same analysis. And this is why we have so many layers of reviewers. So the analysis that we did, we had every week we would meet with our physics working group and then also the physics interest group in order to update them on this is probably very boring for you, but in order to update them on what the status was, what we were working on, and why we were making the choices. And it's not trivial. It's not just sort of like update and go on, because like everyone's a physicist and everyone has an opinion, and sometimes you're making choices that are unprecedented, right? So for example, for the particular shape in the data that we were fitting, it's fairly standard to use a family of models that are well established. So if you read if you go back 10, 20 years and read all the dimuon papers, you're going to find this mention of the same function family. But as we were working on our analysis, we discovered that we needed to constrain the parameters within this function some more. So the existing constraints weren't working. So there was just too many degrees of freedom there. So we came up with this new method of sort of iteratively constraining the parameters that were kind of describing the same thing. And we had to go to bat for that, because it's like they're expecting us to say, oh yeah, we use this and then blah, blah, blah. But we're like, no, this doesn't work. So we came up with this thing. So, proving out that our new method was sound, that it was, not not dumb. It was doing the things it needed to do, not introducing any additional systematic error or error of some sort. It's a process. And because no one else is going to run your analysis, you have to really convince everyone that you're doing things right.
As you were talking, it became clear to me why potentially so many physicists and research scientists get into data science, is because you're having to do all this analysis of data anyway and ask these hard questions. So it sounds very disciplined, which is good, because we're, relying on these things to discover new stuff that we can use in our daily lives. So very, very cool. I've been curious to ask you, like, working at CERN, what is that like to do you take the elevator down to the actual collider very often, like, and go down into the depths, or no?
No. When the collider is running, then no one's going down there because of radiation. And Ideally, it's running most of the time because, you want to collect as much data as possible. But when it is in shutdown mode, upgrade mode, or something's being replaced, you absolutely can go down there if you have a reason. And so there are some tours. If you find yourself in Geneva around shutdown, you can actually get tours that will take you down there. But day to day, there's really not, for physicists especially, there isn't much of a need. There's some hardware folks, there's some engineering folks that, are sort of making sure things are running. But it's more of a curiosity thing. Or if you built a part of the detector, you get to go down and sort of fit it in and like see how it works.
Oh yeah, that's cool. I mean, it's got to be like maybe the most complicated, biggest machine we've ever made as humans, potentially.
I think that's true.
Fun fact, a couple of the Elastic employees back in, I think, 2015 got to go to CERN and go see the collider because they use Elastic to monitor their 5 or 6 systems. And that was back in 2015. So I'm sure it's evolved since then. That was a fun moment for the company and especially for those folks that got to go.
Yeah, I remember when I was at MongoDB, the scientists who had, I don't know if they proved the existence of the God particle, that had done all that analysis on MongoDB at the time. So that was a big deal too.
Yeah. No, we use Mongo. We didn't really, it's not really the layer where the data for analysis lives, but it is the metadata layer is stored in Mongo. So yes, I've definitely, I used MongoDB when I was at CERN. That's the other thing is people think academia is no, it's almost, it's a lot of the same tools. And where it's not the same tools, it's because we had to build something bespoke that was fitted for our particular challenge. It's actually really, really funny. Not last week, but the week before, I gave a talk at CERN on AirFlow and other workflow orchestrators. Yeah, so it was, I was just really, really laughing about it in my head because I've given a lot of talks at CERN and I've also given a lot of talks elsewhere about my work at CERN. For example, we're talking about it right now, but I did not expect to actually, be in a CERN workshop and be the outside expert on some other tool and talk about it.
Would you say that these research facilities are sort of in the same way we think of banks as always pushing technology forward because, hedge funds are always looking for some edge on the markets, doing things a little bit faster, a little bit better than the competitors. Do research facilities kind of work that way too? They're on the leading edge of what software is being used. When you're talking about Airflow, you're talking about Spark or, all that stuff.
Yes and no. It's such a weird dichotomy. So on one hand, we get a lot of cool stuff as byproducts, right? Some really awesome technology has come out of CERN. But on the other hand, sometimes, especially when you're doing these analyses, it kind of feels like you're stuck back in, in ancient times. So it's a combination of both. So physicists generally don't write the best code. I'm gonna, I'm gonna knock myself in the foot there. But so as a result, a lot of our analysis, I'm sure going back now, I'd be able to refactor for every 1,000 lines. I could probably do only 200 kind of thing. So there is that. But on the other hand, the particle collision data, it's event data, and there's many, many, many sensors, hundreds of millions of sensors. So, and then we reconstruct the data from the sensors into particles. So the data structure is very nested. So, it's not tabular data. You can't really easily represent it in tabular forms. So we had to come up with the not just data analysis framework, but data storage framework specific to that data. And when I say we, I mean, this was, this was before my time. So this software, which is Root, it's called Root. If you go and read the documentation or, download and install it and try to run it, you're going to be like, this is so archaic and so dumb and so frustrating. And all of these things are absolutely true. But also, there's no other tool out there, no other data frameworks that we could have used for this, very specific kind of data. And so it's very efficient for how deeply nested the data is. Root is fantastic. So it's just weird.
Well, at least it's not written in Fortran, or maybe it is, I'm assuming, but hopefully not.
So, Chad, I just found the webpage. It says Root enables statistically sound scientific analysis and visualization of large amounts of data. Today, more than 1 exabyte are stored in Root files. The Higgs was found with Root, is what they say.
Oh, there you go. The God
I
particle.
did not know that. This is fascinating. It's written in C++, just in case people are curious.
What is your process for deciding whether you should use off-the-shelf software or whether you should build something totally bespoke and proprietary, like as a science, well, not just at CERN, but also in your current job, which I'm sure we'll talk about in a little bit. Like, how do you think about the build versus buy question coming from your background?
It's always a hard decision, as I'm sure you guys are very well familiar with. I think,
Well, I'm selling software, so I think everybody should buy it. You know, I don't want anybody to build their own stuff.
well, then it's our, I mean, we're all selling software, so it's our responsibility to make sure we build something that, is useful, right? So actually, that's sort of how I ended up that in tooling, is like sort of thinking deeper and deeper about, well, how could this tool be better? So yeah, for me, it comes down, honestly, one of the deciding factors is frustration. So sometimes you'll find a tool that kind of does what you need it to do. And if that's enough, if you're not spending a lot of time within the tool per se, if you're not, routinely getting frustrated by it, that's fine. Okay. But then there is, I can't do this very simple thing that I want to do because of the limitations of the tool. So that level, and it's really hard. Like, I have sympathy as a tool builder, as I'm sure you do. Like, I have sympathy for getting the right level of abstraction for a tool that you're building. It's difficult, but also as a user, if you don't have that right level of abstraction for what you're trying to do and your experience level and what you're used to, then it's just really frustrating. So yeah, so it's a frustration index for me, I think. So personally, as an example, I hate all BI tools. I think most people do, actually. BI tools suck.
Yeah, that's why everybody owns like 8 of them, because none of them do exactly what you want.
Exactly, and no one's cracked the code, and maybe it's either like trivial or it's never going to be cracked, right? So for me, if I need to visualize something, I'm not going to go to a BI tool, right? I'm going to use like Plot. I mean, not that that's super low level either, but like something like Plotly or Bouquet or something, because I know, and partly it's because I know how to do, like, I know exactly the idiosyncrasies of those tools as well. So abstraction's nice, obviously. Otherwise, we would be coding in Fortran. Or assembly, yeah. When I get too frustrated by the limitations of a tool, I think usually is when I reach for something else, or building it myself. And then to be honest, like, so when I worked directly, we had an NLP based product and we were using open source AirFlow and we were using Databricks, that was sort of like the basic stack that we had. And it was really nice to have Databricks, not just for the managed Spark aspect, but also because it's just like, it's a pretty good user experience, right? You're sort of sitting in one place, you're doing your notebooks and so on and so forth. And I didn't mind using AirFlow either. OSS AirFlow was perfectly fine. It's, it wasn't that hard to use or set up for our use cases. And then I went and worked at Astronomer, which is a managed AirFlow service. And my first thing was, I mean, I was excited to work there and whatnot. And definitely my AirFlow experience was something that, they wanted me for as well. But I was like, okay, why would anyone buy us, right? What are we providing? If open source AirFlow is easy enough to use, then what can we provide on top of that would make us appealing? And that's, I think, the sort of interesting question, or I found enough interest in there that I sort of went deeper and deeper, and now I'm at Upsolver, is how do you find out what the needs are that are unmet, and how do you build to that? Because I do think that there are sort of waves of companies or managed versions of tools that don't really add a lot of value, but I think they fizzle out as well. Like, it's like something gets popular and then it's sort of like, actually, is there enough value here? So, but if you can find that, like, this is what's the piece that's missing compared to the open source version or compared to your competitors, that's the differentiator that really.
Yeah, it's interesting. There's a lot of open source projects that are super popular, but there's like no commercial entity behind them. And case in point, like the Log4j exploit that came out a while back. There's no company that like sponsors and sells support for Log4j. And it kind of opened up a lot of people's eyes to, yeah, hey, these developers are not getting paid to do this. And when something goes wrong, it's really not fair to go back to them and like blame them and get all annoyed.
There was also the hack in the XZ library. Someone inserted a backdoor for their SSH key. It's like, it's amazing that someone at Microsoft was even like looking at this and found it, because it's so deep in the bowels of, you wouldn't look at that.
Santona, let's talk about Astronomer a little bit more. Like, Can you tell us a bit about airflow? Because we haven't talked about that on the pod, and I'm not super familiar with it, because I think that'll lead us into kind of your work at Upsolver potentially. So what purpose does it serve in your work?
So it's a workflow orchestrator. Really, at the most basic level, it's a scheduler. So if you have workflows where you need them to run on a timed basis, say every night I want to analyze the data or vectorize the data that have come in throughout the day, okay, it's a good way to be like, okay, run this every day at 12:02. That is honestly the biggest value prop. And I mean, I would say...
So is it like a cron? It's like a cron for machine learning jobs? Is that how you would describe it?
It's a cron for anything. It's just a slightly glorified cron. And not, I mean, I don't mean to like foo-foo it. It's, there are like, you can watch the execution patterns, right? So you can see when things failed, how many times they were retried, and you can set policies.
You just set up a DAG of all the jobs and it just goes through it.
Yep, exactly. Yeah, you set up a DAG of the tasks that need to happen in your workflow, and they happen. And like you set dependencies, so things wait for other things and so on and so forth. More recently, we introduced a dataset-based triggering as well, where it's not schedule-based, but a dataset arrives in an S3 bucket, so you use the S3 sensor to then run the rest of the pipeline. It's Python-based, so you're writing your workflows in Python, and there's a rich ecosystem of integrations. If your workflow is putting data into Snowflake, there's a Snowflake integration. The task is very simple. You're not really having to write a lot of code. You're just like providing your credentials. Like there's a Snowflake operator, there's a Databricks operator, and so on and so forth. In that sense, it's straightforward. It's something that everyone needs. So at CERN, we were using not an abstraction on top of cron, but like a more built out version of it. And that's sort of what airflow is as well. Depending on your workflow, you want to be able to specify different things. With all of that said, the most in industry, contrary to what like I would say as an airflow person, the most commonly used operators in actual production workflows are the Kubernetes pod operator and the bash operator, because that's really all you need airflow for. So like to spin up your pod, and then within that pod, you do what you want to do.
So you're like, oh, I have an EKS cluster. Airflow will spin up a pod in it. That thing will do some work, and then Airflow will spin it back down.
Yep. Yeah.
You were staff data scientist at Astronomer, which I assume is, pretty high in the ranks, in the levels at least. What drew you to Upsolver from Astronomer?
I really like to think about workflow orchestration. So that's what I discovered actually even before Astronomer. So writing ML pipelines and productionizing them, operationalizing them was fun. And so at Astronomer, I got to sort of processize that a bit more and like talk about the broader, like what are the best practices around operationalizing your ML pipelines from that angle. And I really liked the, not to overuse a word, but that abstraction too. Like instead of thinking about my own, production ML pipeline, I was now thinking about how others should do it as well. What are the pitfalls and so on and so forth. So I really enjoyed that. And then, so it's just, Upsolver in some ways was just an extension of that, like other ways of doing workflow orchestration and workflow management. The difference is that, so Upsolver in a nutshell is, and I shouldn't be putting it this way because that's not what marketing wants, but it's a Spark alternative. So we have a processing engine. Spark has its issues, right? So it's it's more efficient and cheaper than Spark. I was talking to folks at Databricks at the time too. So it was sort of like Astronomer to Upsolver was like, okay, from workflow orchestration or scheduler to more like workflow processing. How do you figure that out? And so the other difference is that we work with streaming data. So Airflow is very specifically for batch. It's not well suited for streaming at all. And Upsolver, it's like the separate, different, interesting problems around, how to not do duplicate processing, how to make sure that data is delivered exactly once, and things like that. So those things were interesting as well. And I learned a ton with the transition as well.
Yeah, I bet. Like what are some of the lessons?
Engineers in the data space, right? I think there is you're either doing your batch workflows or you're doing streaming workflows. Like there's like a sort of a different stack and different, so like you almost think of it as a different expertise. So I think I thought that way too a little bit. Like, yes, I'd worked with like Kafka queues and stuff before, but it was sort of like, how do I put these two things together? And so I think one of the biggest things I learned at Upsolver is, I mean, basically it's like two different ways of approaching it, and one works and the other doesn't. So what I mean is, like, you can try to speed up batch, but ultimately you can't reach the streaming limit that way, but you can treat batch data as a stream as well, just by like streaming out one row at a time, and then that approach works. Yeah, it can be unified and it can be simplified. Of course, you have to make some choices along the way, but I think that was the biggest one, is like, it doesn't have to be hard or a big step away from what you're used to.
I like to think about it like a lake versus a river, and partly because the Hadoop vendors were, all about data lakes and stuff like that. So yeah, streaming is a different problem to solve. And plus the context is harder because you're streaming. Like, you're literally watching the river go by and you're just grabbing something.
Right. You can't hold it up.
I like this idea that you had floated of the unified theory of batch and stream data processing, or I think that's how you called it, right? Now, that sounds like a really high-minded thing, and then maybe it is. Like, I'd like to dive into that a little bit, because we talk about the unified theory of physics and whatever, right? So I'm sure it's an homage to that. But what do you really mean by that, a unified theory of batch and streaming?
Yeah, so I mean, this is how we do it at Upsolver. So first, yes, that is the unification we're talking about. Truth is, basically what we're doing is we're taking the stream approach and allowing batch in it as well, because that way you know that you can process, if you receive data, let's say as a batch or in a file or something, as I said, you can treat it as a stream and you don't lose anything. Whereas if you try to stop a stream in a river, if you try to dam it up and do batch work, then it doesn't work. So that's like the cheat code, right? Let's just approach it as a stream.
Okay, but then you're done processing it, like, so are you sort of like pre-calculating aggregations from this batch data that then get factored into a stream processing thing that's happening afterwards, or like, what is actually going on there?
So I mean, it is a tough problem. So we in Upsolver sort of has two different things right now. We have a managed Hive-based lake and a managed Iceberg-based lakehouse, and we do it slightly differently for the two. So in the Hive world, and before sort of lakehouses were sort of as big quite in the same way, what we were doing is we created materialized views on top of the tables that were being fed with streaming data, and you would do synchronized joins with other streams on using the materialized view. So you've data coming in at some cadence X minutes or something like that, and you have another stream coming in that's like coming in real time. So you're just joining with the stream with a materialized view on top of this other table.
And your user is just writing like an HQL, a Hive query language query, and that's what they're
just writing SQL. They're just writing SQL, just straight SQL. I mean, it's Upsolver SQL. We have some certain additional keywords that we define, but basically you do create sync job where select blah blah from this table and join with this other table. And so you're writing the transformation as declaratively in SQL, and then we're doing, when you use that sync keyword and you specify what time field to use in order to synchronize. So here you would want to do like the event time, right, of the stream that's coming in this example. You specify that, you specify your sort of window over which you want these to be synchronized and the results to be updated. And that's all you have to do. Every minute or so, we are doing the joins and aggregating and pushing out the results.
Who are the big competitors in this space? Would this be like Materialize?
Yes, Materialize is one. So the other thing, there's a stream angle and there's the sort of use case angle, right? So a lot of our clients, especially the ones that have massive data, the data that we're handling for them is CDC, change data capture data from their production databases, or their event streams as the applications are communicating with each other, or whatever, messages they're writing out. That's sort of our niche. So a different set of competitors are also like the Fivetrans, where, it's a sort of a data movement solution, a CDC solution, but there are limitations around how small their microbatches can be. So I think 5tran is like 5-minute microbatches.
But 5tran is really very old legacy technology. Like, would you describe yourself as like kind of the new sweet hotness competitor to 5tran? Is that how you kind of want to think about it?
I would, yeah. That's how we would put it. And yeah, I mean, we win. I mean, not to pick on any one particular, but usually when we're doing a POC, we are being compared against something like a 5tran, and then we win on the technical side because we are the sort of, as you described it, new hot technology there. But yeah, so the materialize, the stream, I think STRIIM is one, StreamCap is another one. There are sort of folks who are an estuary who are like talking more about the streaming aspect of data, which we of course do compete with on, but we're just very focused on this like large volume data as well.
Yeah, I remember somebody that I worked with at Cloudera, Eric Sammer, went and started a company called Decodable, which I think is also in this space.
I was just going to ask you for like an exciting use case. I mean, I'm sure you have customer examples of how they're benefiting from your tech, and I'd love to just hear about one so people can kind of wrap their brains around everything we've been talking about.
Initial customers for Upsolver, I think, were in the ad tech space. So when you serve up an ad and you have that ad impression on a user, and they may or may not click on it, and they may or may not click on it right away, right? So there might be a delay between when the ad is served and when they actually perform the action that you want to perform. So joining those two, so when you're serving an ad, you're using some sort of ad distribution platform, let's say Facebook, right? And you're bidding for that digital real estate against other companies, and you have different campaigns running. So you have sort of data in all of these different threads, right? You know, how much am I bidding? What campaign am I running? What platform? And then elsewhere you're having, this individual made this purchase in my website. So sort of putting that all together, that attribution, ad attribution is a big use case. The team that's running the biggest workload in terms of size, I think like close to 100 petabytes a month running, is Unity, and they are doing, so I actually haven't looked at their architecture yet, but their product is app monetization, app and video monetization. So you can imagine they need that real-time attribution as well. Like a creator produces an app and other people are purchasing it and using it and stuff, and making those attributions are important.
Oh, we talked about them before because when Jim Whitehurst was the CEO of Red Hat, and then he left and became the CEO of Unity, great developer. I mean, he's been working with developers for so long, so that's a great platform.
We're also in healthcare. So Centene is using us for, again, like, usually it's like cross-joining data from different sources. So they have different like business areas, business domains that are receiving different kinds of data at entirely different cadences. So insurance claims, and then sort of providers are sending data, right? And then individuals are claiming, insurance companies are doing various things. They use Upsolver as a platform where all of that data is ingested from those different sources. And not only that, but because a different team, it's a large company, so a different team owns each of those spaces, each of those data areas. So I think one of the main reasons that they chose us actually was engineers on these different teams didn't have to learn Glue and Spark and all of these things that they were using previously. They could now just go into Upsolver, create the connection to their data source, and write their transformations declaratively. So for them, it was very much the ease of use aspect of it, like making something that's like under the hood kind of complicated, but if you're delivering a data set or other data deliverable, you don't really need to think about all of that.
Let's talk about the documentary real quick. So, Santona, you did this documentary. It's called Secrets of the Universe. I think it plays in IMAX theaters around the globe, and because I couldn't find a place to stream it online, but I would love to hear from you. Like, how did that come about, and what was that experience like for you?
It came about because my PI is just he's a great guy. He knows a lot of people, and he gets So he was approached by the director and producer. They were like, we want to do a science movie, and he was initially brought in as like an advisor. And then, as time progresses, let's just do it on our research group because that makes sense. He also goes to LIGO in addition to CERN, and part of the movie is about the the gravitational wave experimentation that's going on at LIGO. And it also, the documentary sort of interweaves the present research with like historical, breakthroughs. And so like there's like 7 or 8 scientists from like Nobel Prize winners that are also sort of featured. But it tells a really cool story of, where we are today, how we got here, and what we're looking for. And then personally, it was really exciting to get to work on a IMAX documentary. It was a great way to learn how movies get made. It's fake and not fake at the same time, right? So I think my favorite thing about that whole experience is that like I got to tell my story. And I've always been really passionate about like reaching out, like I don't know if outreach is quite the right word, but like, I talk to high schoolers, I talk to folks in college and grad school, and sort of getting folks excited about science and physics more specifically. And so for me, the fact that, other folks who have my skin color, who share my gender identity, who share, maybe are from Bangladesh or et cetera, and then, they're being able to see me on screen and sort of, getting in some small way inspired by that, hopefully, is very fulfilling. I remember I think the premiere, or we've had a couple of premieres, but at one of the premieres, there's this like maybe 11-year-old kid sitting next to me. There were a bunch of students that were watching it with us, and the movie ends and he's like, "That was the coolest thing ever." And it's like, that is just so awesome to overhear. So that was really fantastic. And in that sense, it's really authentic and really real. Like there was no script. No one's telling me what to say. No one, and we're just... But then the fake part is like we had to do the same, like walking into the cafe scene, like, 24 times. And, it's like, it's a celebration of the end of the run, but actually the end of the run being like the collision run. The actual celebration was like 2 days ago, and that was a great thing, but we didn't film that.
That's right. You got to make one up.
Yeah, it was fantastic.
I love your passion for this. It sounds like you might be teaching at some point, like maybe full time in your future, kind of coming full circle with your physics teacher in the early days.
It's possible.
I bet you would be really good at it.
Oh, thank you.
You have such an excitement for it, and I think you can inspire kids to do the same thing that you're doing.
Yeah.
Thank you. I really appreciate it.
All right. Should we wrap it up?
I think so. Santona, thank you very much. This was great.
It's been a great episode. I love talking with people who came to software from a different background, because you're always going to look at it a little bit differently than maybe how we do. So I appreciate that. And thanks for your time today.
Thank you so much. This has been the most fun.
We aim for that. We want it to be fun. We don't want it to be boring. So we hope you enjoyed yourself here. Thank you. All right, everybody. If you like this episode, please share it out on LinkedIn. That's where most people find us. Of course, you can see us on YouTube, and the video is also available via video on Spotify, and the audio is available anywhere else you get your podcast. So thanks, and have a nice day. Bye-bye.
Thanks, everybody. See you.